Good morning, students. Today we are going to discuss the answer key of test series 6. So let us see the 6 questions that we have. The first question: draw the graph of 3 is equals to 2x plus y. So first, to draw this graph, we need to construct the ordered pair. That means the points with which we can draw a line. So first we can subject either of the two variables. Here we have 3 is equals to 2x plus y. We can subject y. So y is equals to 3 minus 2x. For different values of x, we can get different values of y. So now let us substitute. For x is equals to 0, so we will get y. For x is equals to 0, y we will get equals to 3. So in place of x we are going to substitute the value 0, and then we will get y is equals to 3. Again, if we consider x is equals to 1, then y is also equals to 1. As 3 minus 2 is 1, so we will get y is equals to 1. Now to construct a line, we can take 2 different solution, or we can take 3 different solution. Here I have done with 2 different solution. If you want, you can take 3 different solution as well. So now the solution table will look like this. For x is equals to 0, y is 3, and for x is equals to 1, y is 1. And the graph is like this. Now to draw a graph, it is very important to write the scale that I have written. Here I have considered one box is equals to 1 unit. So the difference between one box is 1. And with the help of this graph and the scale, we are going to get the points 0, 3 and 1, 1. After finding the points 0, 3 and 1, 1, we will join these 2 points to make the line 3 is equals to 2x plus y. So our line is this one, 3x is equals to 2x plus y. And the points are, you can see 3, 0 is over here and 1, 1 is over here. So this is how we construct a line in graph. Question number 2. In figure, the side QR of a triangle PQR is produced to a point S. If the bisector of angle PQR and PRS meet at the point T, then prove that QTR is equals to half of QPR. So first of all, given is QT bisects angle PQR. So we will get PQT is equals to TQR, or we can also write half of angle PQR is equals to TQR. Similarly, RT is also the bisector of angle PRS. So we can write PRT is equals to TRS, or we can also write half of PRS is equals to angle TRS. So to prove QTR is equals to half of QPR, we need to prove this. So to prove this, first we will consider the triangle PQR. Now in this triangle PQR, the exterior angle is PRS, and we know that exterior angle is equals to sum of interior to opposite angle. So PRS is equals to PQR plus QPR. After that, we divide the equation with 2. So we will get half of PRS is equals to half of PQR plus half of QPR. Now from the given we can write PRS is equals to TRS, half of PRS is equals to TRS, and half of PQR is equals to TQR. The third part, this part remains same. So this becomes our first equation. Second, we consider the triangle QTR. So this triangle we will consider. In this triangle, the exterior angle is equals to sum of interior to opposite angle. So the exterior angle is TRS. We can write it as TQR plus QTR. This becomes our second equation. Now in both the equation, the the left hand side part is same. So we will equate only the right hand side part. So we will get QTR plus TQR plus QTR is equals to TQR plus half of QPR. Now these two parts are same angle, and they are same inside but in both different sides, that is one is in left and another is in right. So we can cancel it off. So we can write QTR is equals to half of QPR. So our required to proved is achieved. Here we have used the exterior angle property. Question number 3. ABCD is a rhombus and PQRS are the midpoints of the sides AB, BC, CD and DA respectively. We have to show that PQRS is a rectangle. So from a rhombus, using its midpoints, we have to show it is a rectangle. So the diagram is like this. You can see ABCD is a rhombus. The midpoints are P, Q, R and S, and they will form a rectangle. So let us see how to prove. First we will consider triangle ABC. In triangle ABC, P and Q are the midpoints. So using midpoint theorem, we can say PQ is parallel to AC and half of AC. Now we will consider ADC, that is the part, this one, ADC. Here S and R are the midpoints of the sides CD and DA respectively. Here also we will use midpoint theorem, and we can say RS is parallel to AC and half of AC using midpoint theorem. So from relation 1 and relation 2 we get PQ is parallel to RS and PQ is equals to RS. Since opposite sides are equal and parallel, we can say PQRS, the quadrilateral PQRS, is a parallelogram. So here PQRS, one pair of sides, opposite side is equal and parallel to each other. So it is a parallelogram. Now we have got a quadrilateral which is a parallelogram. Now we have to show that it is a rectangle. To prove it is a rectangle, we need to show that the interior angle is this interior angle is 90 degree. So now we know that the diagonals of a rhombus bisect each other, and they bisect each other at 90. So these two things we need to remember. The diagonals for ABCD is a rhombus. The diagonals are BD and AC. They bisect each other at O. So now we get a quadrilateral OMQN. This quadrilateral OMQN. In this quadrilateral we can say we have already established that PQ is parallel to AC. So we can say MQ is parallel to ON. Similarly, we have also established that QR is parallel to BD. So we can also say QN is parallel to OM, as these are the parts of the parallel lines. So together the quadrilateral OMQN becomes a parallelogram. The reason is opposite sides are parallel. We have shown opposite sides, both the opposite sides are parallel to each other. Since the opposite sides are parallel, we know that in a parallelogram the opposite angles are also equal. So angle MQN is equals to MON, and this implies PQR is equals to MON. Now we know that in rhombus the diagonal bisect each other at 90. So the angle at O is 90. Similarly, we can say that the angle at PQR is 90. So the reason is diagonal of rhombus are perpendicular to each other. So we know that MON is 90 degree. Hence we can say PQR is 90 degree. So clearly we have got PQRS as a parallelogram whose interior angle is 90. So we can say it is a rectangle. Now question number 4. In question number 4, two sides AB and BC and the median AN of the triangle ABC are respectively equal to PQ, QR and the median PN of the triangle PQR. We need to show two congruency. So here first the thing is given AB is parallel to PQ, BC is parallel to QR and the medians AM is parallel to PN. We need to prove triangle ABM is congruent to triangle PQN and triangle ABC is congruent to triangle PQR. So to prove it, first is we will consider the triangle ABM and PQN. In the triangle ABN and PQM, we already have BM is equals to QN. This we can say that by we are given that BC is equals to QR. So half of BC is BM and half of QR is QN. So we can say that BM is equals to QN. The reason is given in the bracket. As BC is equals to QR, so half of it is BM, so BM is equals to QN. Next, AB is equals to PQ, it is given in the question. And the medians AM and PN are equal, they are also given in the question. So by triple S congruence rule, we can say that the triangles are congruent to each other. The triangles are ABM and PQN. Now in these two triangles, since these two triangles are congruent, we can say the angle B and angle Q are also equal to each other by CPCT. This we need to prove the congruency in the second part. So angle ABM is equals to angle PQN by CPCT. Now we need to prove the congruency of the triangle ABC and PQR. In the triangle ABC and PQR, AB is equals to PQ, that is given. Angle ABC is equals to angle PQR, that we have proved above in CPCT. And BC is equals to QR is also given. So by side angle side congruency rule, we can say that the triangles are congruent to each other. So this is how two congruency we have proved in sum number 4. Now sum number 5, factorization. We have two different kind of factorizations, and in this two different kind of factorizations we are going to use two different identities. So the first one is 2x square plus y square plus 8z square minus 2 root 2 xy plus 4 root 2 yz minus 8 xz. So here we are using the identity a plus b plus c whole square is equals to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So here a square is given as 2x square. So we can write a as root 2x. Y square can be written as minus y, as from the following part of the question we can see that there is a minus sign involved. So we are going to make y as minus. Again 8z square can be written as 2 root 2 z whole square, rather minus 2 root 2 z whole square, as like before I have said, from the last three terms we can see that there is a minus sign involved. Now by the formula we have 2ab, 2bc and 2ca. So with the help of the formula I have written everything in plus, and wherever we have given the minus sign, for accordingly we have used it. So plus 2 from the formula, root 2x from our x part, and minus y from our b. Similarly, 2b square can be written as 2, b is minus y, and c is minus 2 root 2 z. And the last term 2ca can be written as 2, c is minus 2 root 2 z, and a is root 2 x. So this 6 terms can be written as root x, root 2x minus y minus 2 root 2 z whole square using the identity, and hence we can write it as the multiplication of the two same brackets, that is root 2x minus y minus 2 root 2 z. So this is our first factorization. Second factorization, we are going to use the identity a minus b whole cube is equals to a cube minus b cube minus 3ab minus a minus b. So for the first term is 27p cube. We know square cube of 3 is 27. So 3p whole cube is the first term, and cube of 6 is 216. So it is written as 1 by 216, so it can be written as 1 by 6 whole cube. Now we have already found out a and b. Rest we will substitute in the formula. So minus 3 is from the formula. A is 3p, b is 1 by 6. A minus b, the bracket is 3p minus 1p. Now when we evaluate, or when we find out the value of this part, we can see that it is minus 9 by 2p square plus 1 by 4p. So we are getting the previous term. So using the identity, we can write 3p minus 1 by 6 whole cube, which can be written as 3p minus 1 by 6 into 3p minus 1 by 6 into 3p minus 1 by 6. So this is the factorization. Lastly, we have to plot the following points in the Cartesian plane. So here the point 3 comma minus 3 comma 7 is taken as A, minus 1 minus 3 is taken as B, 2 comma minus 3 as C, and 0 comma minus 3 by 5 as D. And I have written the scale as 1 box is equals to 1 unit for both the axes, x-axis as well as y-axis. And here is our Cartesian plane. You can see we have plotted the point A, that is minus 3 comma 7, B minus 3 comma minus 1, C 2 comma minus 3, and D, which is on the axis, rather which is on the y dash axis, is 0 comma minus 3.5. So these are the 6 questions that we have discussed in the test series of 6. I hope this tutorial is helpful for you. Thank you.